Now we'll go ahead and wrap up our second section with functions by looking at something called function notation. To denote that y is a function of x, meaning that y depends on x, we actually just can replace y with what we call f of x. That's how we read that is f of x. Then again, that means that y, the output, depends on x, the input. Because of this, y is considered our dependent variable, while x is our independent variable. So if we want to take a linear equation like y equals 4x plus 3, we can rewrite it in function notation by replacing y with f of x. This gives us a shorthand method of writing the equation that emphasizes the fact that it is a function. Think of functions as like a machine where we have a rule applied to every input value. So if I have a function f, I have some rule or correspondence that's applied. We take our inputs and we put them into our machine, and then we are given our function as an output. I can apply a different rule or a different function, such as g. I can take my input of x, apply the rule, and then I get output a function of g of x. The notation, when we have a function, when we replace x with a number, such as f of 1, this is read as f of 1, replace x with 1 and we find the result of the function. So when we look at our original function back here, f of 1, we replace the x with the 1 and then we can evaluate our function, which is applying our rule, and we get f of 1 equals 7. And because we're finding corresponding x and y values, when we're evaluating a function, this function notation gives us an ordered pair that corresponds to the point 1, 7. So we can go ahead and evaluate a few functions given the specific values and then identifying the associated ordered pair with each of those. So with f of 1, we're going to take our function f of x and replace x with 1 and simplify the equation. 1 squared is 1 times 7 is 7, minus 3 plus 1. 7 minus 3 is 4, plus 1 gives us 5. So f of 1 equals 5, and that gives us the ordered pair 1, 5. G of 1, we're going to look at our function g of x and replace x with 1. 8 times 1 is 8, minus 2 is 6. So g of 1 equals 6, which gives us the ordered pair 1, 6. F of negative 2, we take our function f of x and we replace x with negative 2. Negative 2 squared is 4, times 7 is 28, plus 6 plus 1. 28 plus 6 gives us 34, plus 1 equals 35. So we have the ordered pair, negative 2, 35. And then we can look at g of 0, where we replace x with 0. So 0 minus 2, g of 0 equals negative 1, giving us the ordered pair, 0, negative 2. And then we also can use function notation as part of real-world problems and word examples. We have the function given f of x, which predicts the number of 4-year degree-granting post-secondary institutions in operation in the United States as a function of time, where x is the number of years after 2010. Use the function to predict the number of 4-year degree-granting institutions in 2025. Well, we have to figure out what our x value is, since x is the number of years after 2010. So x will be equal to the difference between 2025 and 2010. So x is 15. So we can evaluate for f of 15 by substituting 15 into our equation. So we plug all of that into our calculator to evaluate, and we get 1,060 1,633. So we will have 1,633 four-year degree-granting institutions in the year 2025. We can also use graphs to evaluate functions because a graph lists all the ordered pairs in a continuous notation. So we have two functions here. We have function f and we have function g. And so we can look at functions f and g. F of 4. We're going to look at function f and we're going to find the x value of 4. So on function f we have an x value of 4 which corresponds to this point up here on the graph, 4, 2. Since the x value is 4 and the y value is 2, f of 4 equals 2. We can look at f of negative 2, find the x value negative 2, find the corresponding point, it's negative 2, 1. If x is negative 2, our function evaluates to 1. Then we can look at g. G of 1, we find the x value that corresponds to 1. That's the point 1, negative 1. And so g of 1 evaluates to negative 1. Then we look at g of negative 2. The x value that corresponds to negative 2. We have the ordered pair negative 2, 2. So g of negative 2 equals 2. Now we're going to find g of x that equals negative 4. Find x. So what x value outputs negative 4? So this means we actually need to look for a y value of negative 4, which corresponds with this point over here, negative 5, negative 4. So in order for g of x to equal negative 4, x must equal negative 5. And then we want to find all values of x such that f of x equals 1. Again, this is a y value, so we go and look at f of x, and we see where we get y values of 1. Well, it's the point negative 2, 1, as well as the point 2, 1. So all x values such that f of x equals 1 is that x equals negative 2 and positive 2. And there's our introduction to functions.